Good evening, guys. Going to look at tangent and cotangent here in this video. Tomorrow we'll look at graphing these in class, but it is a little bit different graphing tangent, cotangent. Secant and cosecant, if you know how to do the cosine and sine, you're in pretty good shape, but these are a little bit different. So day 27 notes here. What I've done is I've already given you the picture for tangent and cotangent. Remember that the tangent is the sine divided by the cosine, and cotangent, we just take the reciprocal of that, and we have the cosine divided by the sine. But you'll notice that the graphs look a little bit different than what we've been doing. We still will graph 5 points, but 2 of the points that we will graph will be vertical asymptotes. So we'll actually only graph 3 points, and then 2 of our coordinates will be our vertical asymptotes there. So the start and the end will actually turn out to be vertical asymptotes when we graph tangent and cotangent. For the tangent graph, you'll notice that it has a left-hand vertical asymptote at -90 and a right hand at +90. Goes through 0, 0, and it is increasing as we go from left to right. And then basically we flip that for the cotangent, but notice that the graph does shift over. We start at 0 with our left-hand vertical asymptote, and we move to 180 for the right-hand asymptote, and notice that it is decreasing as we go left to right. And also notice that it does not go through 0, 0, it goes through 1, 0, but we've shifted everything over from the tangent. A couple other things to note with these graphs is the period is no longer 360. With sine, cosine, secant, and cosecant, we had a period of 360. Now, if we need to find the period, we're going to use 180, or if we're doing radians, we'll use pi. So we will not do 360 divided by b, we'll do 180 divided by b. The vertical shift stayed the same, it is still d, which we will use that. Now, one thing to note that is a change from what we've been doing. Notice that the standard form here, a tan, and a is still a number out in front, but notice now it says bx plus c. With tangent problems, typically the b is distributed through, so we're looking at whatever's in parentheses here after the tangent, we're going to use that. So if there's a number out in front, like we've been using with sine and cosine, we've been putting the b out in front. If that is the case, then we want to distribute that because we need the b to be in with this when we solve for that. And the same thing for cotangent, the bx plus c. And then another thing that we have to find with these are the vertical asymptotes. Now, when we find these, we're actually finding our start and our ending. The left-hand vertical asymptote will be the start, the right hand will be the end. And here's the way we find these. For a tangent problem, here we're under tangent, we take bx plus c and we set it equal to -90. Now, why -90? Well, because when we go back to the original tangent graph, that is our left-hand asymptote, was -90. So that's what we're going to use. And then to find the end, you do the same thing we've been doing. You take your start, which would be what you just found, and add your period. And the same thing over here for cotangent, except instead of setting it equal to -90, we're going to set it equal to 0 to find our left-hand vertical asymptote. And once again, because 0 is our left-hand vertical asymptote up here. So let's take a look at an example. I'm going to give you 2 examples here, and they go pretty quick because there's not quite as much to graph. But I'm going to give you 2 examples, and then both of them have degrees, and then we'll do a ratings example in class tomorrow before I let you work on your problems, okay? All right, so here in this problem, graph 2 tan x minus 90 plus 3. The 2 is my A. B is 1. It's in front of the x there. 90 is still the C, and then that is D. So now, to find the period, we do this a little different because the period for these are 180. So we take 180 and we divide it by B. So for this problem, I'm going to have 180 divided by 1. All right, and so the period for this one is going to be 180. Now this is key because remember we use the period to find our increments. So if you use 360, it's going to throw these increments off. The vertical shift for this problem, still doing the same thing. It's D, which is 3, and that actually is going to be the middle of my graph. That'll have some significance here in just a minute as I'll show you. To find the start, the left-hand vertical asymptote, if you look back up here, remember we're going to take bx plus c equals -90. So whatever's in parentheses here after the tangent, which is x minus 90, I'm going to take that and I'm going to set that equal to negative 90. And so when I solve this, we add 90, so I'll get x equals, not 180, I was about to write the wrong answer there. We get x equals 0. So my left-hand vertical asymptote is 0. Now, to get my right-hand asymptote, I simply take that left hand and I add the period to it. So 0 plus 180 is 180, and that's what we've been doing all along. And then my increments are still the same thing, my period divided by 4, and 180 divided by 4 is 45. So I'm going to go ahead and fill in my, my numbers here, my x values. We're going to start at 0, and then we're going by 45. So we go 0, 45, 90, 135, 180. Now, this is really not that bad once you get these points, because we know that the first one and the last one are vertical asymptotes. So I don't even have to find points for that. Those are going to be vertical asymptotes, and I put them on my graph. Okay? It turns out that this middle one is on the vertical shift. So my vertical shift here was 3. So this is going to be my vertical shift there, that middle one. Okay? Now, you can do this one of two ways. You know, you could obviously plug in the 45 and plug in the 135 and get your answers there for these. But notice that we didn't talk about an amplitude here. And the reason we don't is because technically cotangent and tangent do not have an amplitude. But they do still have an A value. And that A value we can use to determine my next 2 points here. Now, just like we did with sine and cosines, you know, we had a max and a min. And the way we would find the max is we would add our A value or our amplitude, and the way we found the min is we subtracted our amplitude. Okay, so in this case we're not really finding a max and a min, but we are finding these two coordinates. And since this is a positive number, this first coordinate here would be kind of the same way we found the max. So I'm going to add my A value to this 3. So 3 plus 2 is going to give me 5. And then to get this one, I'm going to subtract it. So 3 minus 2 is going to give me 1. And now, all we need to do is to plot our points. So we know we have 0, 45, 90, 135, and 180. And I know that 0 is a vertical asymptote, and 180 is a vertical asymptote. Okay, and then this middle point, 90, is sitting right in the middle of my graph. So the middle of my graph is at 3, which, notice, that is the vertical shift. That's kind of like the sinusoidal that we've been talking about earlier. And then, actually, I'll tell you what, I have mixed these 2 points up, and I apologize for that. Okay, we know that, that a tangent graph should be increasing as we go left to right. Okay, so we know that we're starting down here, and we know that we're going up in this direction right here. So I did put those in the wrong place. I should subtract my A value from this to get 1 here, and then I should add it to get 5 there. I messed that up. Sorry about that. And the reason I know that is because it has to be increasing as I go left to right. So at 45 I'm going to be at 1, and at 135 I'm going to be up at 5, and I need to add a mark on my graph there. I'm going to be up here at 5 right here, and now my graph looks something like this. And there we have a tangent graph. Okay, there we have tangent. And again, just since I messed this up, let me kind of go back over this. I know that this one is in the middle. That's the 3 right there. But the way I determine these would be based on how my graph is supposed to go. And I know that tangent increases as it goes left to right. So this point right here has to be lower than that point. So this one's actually going to be 2 away from that one, 2 below it, which would be 1, and this one would be 2 above it, which would be 5. All right? Okay, let me do one more. Let's do a cotangent problem. And maybe I won't mess this one up here. So cotangent, same thing as we were doing before. Let's see, 3 cotangent 1/2 x minus 45 plus 1, period. We take 180 divided by b, and b in this case is 1/2. And when you take 180 and you divide it by 1/2, you have to do keep change flip. So that is going to make this actually turn out to be 360. My vertical shift is 1. For the left-hand vertical asymptote, remember, since it's a cotangent problem, we take what's in parentheses and we set that equal to 0. So 1/2 x minus 45 equals 0. So we add 45 and then multiply by 2, and we come up with x equal to 90. That's my left hand. And now if I take that and add my period, I get the end, or my right asymptote. And then the increments again is period divided by 4, and 360 divided by 4 is going to come out to be 90. Okay, so the coordinates that I'm looking at this time, we're going to start at 90. We're adding 90 each time, so 90, 180, 270, 360, and 450. Now remember, the first one and the last one are always vertical asymptotes for tangent and cotangent. So what I'm going to do is I'm going to go ahead and fill in my graph here. We're going to go 90, 180, 270, 360, 450. Put that in, and I'm going to go ahead and put my asymptotes on here. Okay, right there. Now, we also know that the middle one here, the 270, has to be on the vertical shift. So that's going to be at 1. So I'm going to go ahead and plot 270 here at positive 1. Now, the other 2 points are 180 and 360. And this is what I messed up on earlier, and I'm not going to do it this time. We know it's a cotangent graph, so it should decrease as I go from the left down to the right. So this 180 should be a higher point than the 360. So to get this point up here, I'm going to look at my A value, and I'm going to add that to the middle. So from here, I should be going 3 units up. So 1 plus 3 puts me at 4. So with 180, I'm up here at 4. And then here, the 360 point should be lower because I am decreasing. So I'm going to subtract 3 from that. That's going to put me at negative 2 down here. And so now I can draw my cotangent curve based off of that. All right, I will do an example of radians tomorrow in class, and please come with questions that you have on any of these two so we can get those cleared up. See you guys in class tomorrow.